Hello everyone, this is our first video. Here first we start with RCC design. The topic is the calculation of moment of resistance of beams. We know in beam we have two types. The first one is a singly reinforced beam and the second one is doubly reinforced beam. In singly reinforced beam, reinforcement will be provided only in the tension side. Whereas in doubly reinforced beam, reinforcement is provided in two places, that is in tension side as well as in compression side. That is, let us consider a example beam which is simply supported. For simply supported, we know if load acting downwards, it will bend like this. So let us apply this to this beam. When we apply the load, so beam will bend like this. So it results into the bottom will be the tension side, whereas the top will be the compression side. In singly reinforced beam, will provide reinforcement at the tension side only, whereas in doubly reinforced beam will provide reinforcement in both, whereas that is both, that is tension and as well as in compression side. Now we'll study one by one. Let us consider the first one, that is singly reinforced beam. Let us see how to design singly reinforced beam, that is to calculate the moment of resistance in case of singly reinforced beam. Here the first step is, as usual, collect the data given and draw a sketch which shows the details given. Then second step, in second step we have to calculate the overall depth of neutral axis, XU. In second step we have to calculate the overall depth XU. We'll see how to calculate this XU using codebook later. The next step is to calculate the maximum depth of neutral axis, that is XU max. It is also we have to calculate by using the codebook. The next step, after calculating this XU and XU max, we have to compare them. That is, if XU is less than XU max, it is under reinforced beam, under reinforced section. If XU is greater than XU max, it is over reinforced. We are designing here, we are calculating moment of resistance using the limit state method. According to limit state method, the structure should not be over reinforced. The beam should not be over reinforced. For our calculation purpose, we will going to consider this over reinforced beam as balanced section. That is, we are going to consider XU is equal to XU max. By considering this condition, we will calculate moment of resistance. Our next step is to the calculation of moment of resistance. In simple word, in calculation of moment of resistance, we have to calculate first X, then XU max. After that, we have to compare them. By comparing them, we'll get to know which formula we have to use to calculate moment of resistance from IS 456-2000. Now we'll see how to observe the formula, that is which formula we have to use to calculate XU and XU max and MR using IS 456-2000 from codebook. First, to calculate XU, here we have the formula, that is from IS 456-2000, page number 96. We have in G1.1, that is formula A. Here this formula we are going to use to calculate XU. that is xu is equal to this much. Then to calculate xu max, we'll use the formula which is given in page number 70 of IS 456-2000. That is, they have given xu max to the effective depth ratio. By using this, we can calculate xu max. After getting xu and xu max, after comparing them, we'll get to know whether it is under reinforced or over reinforced. Then from page number 96, we'll use these two formula, that is, which is given in G 1.1b and C. If the section is xu is less than the limiting value xu max, if it is under reinforced xu is less than xu max, we'll use this formula. If xu is equal to xu max, that is over reinforced, so that is which we got xu is greater than xu max, that is over reinforced. We'll assume that as a balanced section and we'll use this formula. Like this, we have to calculate moment of resistance. We'll see how to solve the problem too. Thank you.